Okay, so on your test, you are going to be asked for the first problem. You might get this in a different order, but one of the problems will ask you to solve for t. Okay, so it's going to ask you to solve for t with some expression that's going to look something like this. It's going to be like, okay, and so it's going to ask you to solve for t. And we can go through how to solve, but I just kind of want to make you a running list of everything. Okay, the next one is going to ask you about simple interest. Okay, and that's dealing with the p times 1 plus r raised to the t power. The next question is going to ask you about solving something that looks like this. And they're going to say solve for v. So basically, you're either solving for the solution or you're solving for your exponent. Okay, the next one's going to ask you about rate. Okay, and we'll come back to that one in just a second. And then the next one's going to ask you about solving for t and kind of like setting up the equation. The next question has a couple of parts to it. So it's going to say which one of these are true. And so it's going to give you a bunch of equations, and it's going to say which one of these are true. Okay. The next one's going to ask you about if there's this solution, which one of these equations does it work for? The next one is asking you to graph. Okay, so it gives you the equation, and then you actually have to pick out the graph. The next one's about literal equations. The next one is talking about vertical asymptotes and end behavior. And the next one's asking about a word problem and kind of like interpreting what different pieces of it means. Okay, so the next one's going to be a word problem, and I know y'all don't like word problems, but it's kind of like asking about a population. And then the next one is if you have a graph, then what is the equation? Okay, number 8 was if you had the equation, what was the graph? If something doesn't make sense. So this one says rewrite the following function in exponential form. Remember, when we write this in exponential form, we're going to start with our base, go to the outside, and then finish over here. So we've got 9 to the second power equals 81. Okay. And this was the first thing that we kind of learned with logs, rewriting them in exponential form. On number 6, same thing. You're going to start with your base, go to the outside, finish over here. So 3 to the 5th power equals 243. Okay. So let's actually do the opposite. Let's go back the other way. So on number 8, we have it in exponential form, but now we want to put it in a log form. We still do the exact same process. We start at our base, we go to the outside, finish at our exponent. So we go log of base 8 of 64 equals 2. So on number 9, we're going to do the same process. We're going to go 3 over to 81, finish our exponent. So we'll have log of base 3 of 81 equals 4. So on number 11, we've got 6 to the log of base 6 of x minus 2. If you have a base that is the same for the exponent of the log, the base of the log and the base of the exponential, then those cancel out. So for instance, I have log of base 6 of log of base 6. So that's going to cancel out. We're just going to bring down the x minus 2. So over here, if I rewrite 9 in terms of 3, look at what happens. I've got log of base 3 of 3 squared. So this will cancel out, and so I'll just be left over with 2x. So it says, suppose you purchase a house for $275,000 in 2010, but the value of the house is supposed to increase by 8% each year. Write a model to represent the value of the house for t years. So in order to write this model, we're going to remember the formula, which is a equals p times 1 plus r raised to the t. Okay? Where p is my initial, r is my rate, and t is my time, right? So for the initial amount, it's $275,000. I got 1 plus, and my rate needs to be turned to a percent. So, or a decimal, I'm sorry. In order to turn it from a percent to a decimal, I'm going to move it over 2 places and put a 0 in front, right? So that's going to give me 0.08 raised to the t power. Now it asks how much is the house worth in 2015, okay? So in order to figure out how much the house is worth in 2015, I would plug in 5, because between the years of 2010 to 2015, there were 5 years. So I'm going to plug in $275,000 times 1 plus 0.08 raised to the 5th power. And then I'm going to go into my calculator, and I'm going to say 275,000, 1 plus 0.08 raised to the 5th power. And that's going to give me 404,065.22. So let's say that it asked you to solve for t, okay? So let's say it asked you to solve for t. So in order to get t by itself, what we're going to do is we're going to divide by 275,000 first. Okay, so let me actually get you a color that you can see. So we're going to take a equals 275,000 of 1 plus 0.08 t. We're going to divide by 275,000 first. And so that's going to give us a divided by 275,000. This can be combined, 0.08. Raised to the t power. Okay? Now in order to get t by itself, we're going to use the circle of life. So we're going to start from our base of 1.08 and then finish at our exponent. So we're going to get log of base 1.08 of A divided by 275,000, and that's going to equal T. Okay, and there's two problems that look a lot like that on your test. Now, there is a problem that actually asks you to solve for like B, and it's going to look like this, but again, you would just do the circle of life and then solve for A. So we would get this equation if we solve for A. So you should be able to go backwards and forwards, and that's two problems are going to be solved for T, one's going to be like solved for A on your test. So on 20 and 21, what's going to happen is we're going to take this function and we're going to plug it into our Desmos calculator, or if you've got a graphing calculator, that works too. Remember, ln is the natural log. So another way of saying ln is log of base E. So we're just going to type it ln because I like the shortcut method. Okay. And so once we graph this, we can then go over here and graph it by hand. However, what you're going to be asked to do is just pick which one is the graph. So obviously find this graph and then go, okay, well there's a point at 4.1350. So when I come over to my graph, there should be a point at 4.1350. Okay? And if there's not, then obviously that's not your graph. Okay? Talking about in behavior really quick though. Okay, so on in behavior. In behavior is if I'm standing right here at 0, 0, and I look to my right, what's happening to my y values? They're going up, right? If I look to my left, what's happening to my y values? They're going down, right? Okay, or as x approaches 4, because we're not actually going to go to infinity, but okay. One thing that I'll do when I mention is the vertical asymptote that happens here. So if I go into my Desmos calculator and I go to my table and I plug any number in less than 4, I get undefined. And the reason why I get undefined is because there's a vertical asymptote at 4. This number right here will be your vertical asymptote. Why is it positive 4 instead of negative 4? Well, the reason why is because from our function that we always write out, and hopefully y'all remember this, y equals a times log of x minus h plus k. Okay, that negative is already in the original function. Okay, so our vertical asymptote is at 4. X equals 4. So it will never pass 4. It'll get really, really, really close, but it will never pass 4. Okay? On 21, though, it's a little different story. So we can go in, and on 21, you're going to probably have to use Desmos, because otherwise you can't do this little base 5. So when you come in here, you're going to do log of base 5 of x, I think it was minus 3. Yep. Okay? And when we do that, we get this graph. So when we come back in here, we've got a point at 4 comma, I'm sorry, 0.2 comma negative 4. And we've got another point at 5 comma negative 2. So when you graph this, it does not have to be completely perfect. It can just be like a rough sketch. Yes, ma'am. Yep, cool. Okay. But notice how our vertical asymptote is 0. Our vertical asymptote is 0 because there's no parentheses around this x. So there's not a minus 4 inside of the parentheses. This minus 3 happens outside, which is what brings it down just a little bit. okay? The in behavior is as x